Hello, my name is Kevin Treader, product marketer with Microchip Technologies Analog Division. Welcome to this edition of Amp-titudes, where we will take a closer look at input bias and input offset current. Although related, these two specifications highlight different characteristics, and both must be taken into account when calculating a signal conditioning error budget. Let's take a moment to address the actual definition of these two specifications. The two physical currents that flow into an op-amp's non-inverting and inverting inputs are shown here as IB sub n and IB sub I. Convention dictates that for input leakage, a current into the device is positive, and current out of the device is negative. Input bias current is defined as the average of the currents into the two input terminals of an amplifier. Input offset current is defined as the difference between the currents into the two input terminals of an amplifier. Now let's rearrange these two equations in terms of the actual currents at the op-amp inputs. With traditional operational amplifier input structures, the inputs are closely matched in terms of bias current, so the offset is typically very small and hence can be ignored in most cases. However, for more complex architectures, this is not always the case. Take the MCP6V06 zero drift amplifier from Microchip. The datasheet for this device specifies a typical bias current of +6 picoamps at room temperature, but a typical input offset current of -85 picoamps at room temperature. Unlike traditional op-amp input stages, these zero drift operational amplifiers have switches at the inputs that add a current flow path through parasitic switch capacitances. It turns out that the current flows through the switches from one input pin to the other. So for the MCP6V06, IB sub n is approximately -37 picoamps, and IB sub I is approximately a +49 picoamps. This means that the non-inverting input is sourcing current, while the inverting input is sinking current. Even though the average input current is relatively small at 6 picoamps, the offset current is actually quite large. As noted earlier, this is a function of the self-correcting architecture of the zero-drift amplifiers and is uniquely different from the characteristics of a traditional op-amp. Although input-offset currents can typically be ignored for standard op-amps, the offsets may be a factor in working with these specialty amplifiers. Thank you for joining me for this edition of Amp-titudes, where we took a closer look at input bias and input offset currents. For more information, please visit www.microchip.com/linear. I'll see you next time.